Hey everybody, another video about astronomy. I love astronomy. I love everything that's related to exploring and learning about the universe here and elsewhere. Can there be a here and elsewhere in the universe? I guess so. There's here and then there's the elsewhere. Anyway, or the tonal in the novel, as Carlos Castaneda used to say. Woo-hoo. Anyway, that's another subject. I was reading about the how the exoplanets. I think that's what it's called. The investigation of planets outside of our solar system, which has really begun in earnest. We have actual observatory systems in operation now that are dedicated to that. And whereas just a few years back we were finding one or two, now we're finding dozens of planets observed outside our solar system. We've got new technologies that are being employed to that task. Everything from noticing the gravitational wobble that occurs to a star as a planet goes around it, to the diminishing of light as a planet passes in front of a star, and you can see the light diminishing. There's a number of different ways, and lensing also. There's a lensing effect occurs that in the light, the gravitational lensing as there's a planet that's influencing the light. Very fine sensitivity. Now that's a whole world in of its own to talk about how in such fine detail we're able to explore the universe. Now it makes me think that a more advanced civilization would have no need to really leave its front doors to examine the universe. If we are able to detect such things in such fine detail now, imagine what a more advanced civilization would be able to do. Let's go this way so we don't scare this woman that's coming down the road because of my camera. Anyway. So, back on task. Exoplanets, we are discovering them, so many of them, and some of them are truly, truly fascinating places. In all kinds of configurations, we're finding solar systems that have multiple planets, not just one. And sometimes the gas, in our case, in our solar system, the rocky planets are inside and the gas giants are on the outside. But we're finding solar systems where it's the opposite. The gas giants are on the inside, the rocky planets are on the outside. There's all kinds of stuff going on. But what the news that's causing me to make this video was the proposition sent forth that it seems that it is likely that all and this is again just in the pulp science news feeds that I'm reading, so take this with a grain of salt. I'm just reading my science magazine, so to speak. But the announcement I read this week was that it appears that researchers are determining that or speculating that planets are the norm. That probably all stars in our galaxies have planets, at least one, and possibly maybe 5 or more. And just think about that. Think how stunning that possibility is. When I read that, I put me back on my heels. Now, this is just speculation, of course. It's not confirmed. But just if that's true, think about how stunning that is. There are an astonishing number of stars in our galaxy, billions upon billions in our galaxy alone. And if there are planets with every single star out there, I actually asked Siri, how many if that's the case, then the article that I read said there could be up to 1 trillion planets in our galaxy alone. 1 trillion planets in our galaxy alone. Now, I asked Siri, I didn't know how many galaxies there were in the universe, so I said, Siri, how many galaxies are in the universe? And it gave me an answer, and I had to write it down. 1.7 times 10 to the 11th power. 1.7 times 10 to the 11th. Now that's a far bigger number than I can say, let alone comprehend. A really, really astonishing number of galaxies speculated at this point. Look at any images such as the Hubble Deep Space image, or the Hubble Deep Field image, or the Hubble Ultra Deep Field image, and you really can see how that can be the case. Now imagine then if there are 1 trillion planets. Remember, this is all just fun speculation. If there are 1 trillion planets in our galaxy alone, multiply that trillion times this 1.7 times 10 to the 11th. And you have worlds without number. I mean, truly more than the imagination can fathom. And what makes me more excited of all is to imagine then, with so many worlds, your imagination can run free. As long as you stay within the bounds of science, or the bounds of the physical laws of the universe, if you imagine it, if you can imagine a world, it probably exists. Anything from mighty gas giants, you know, surrounded by scores of moons, to diminutive dwarf planets doing all kinds of strange things. Planets close to stars, planets that orbit, and we've even seen planets now that have survived being engulfed by their stars. Planets that maybe include an orbit that takes them close enough to be burned by their stars, and then greatly elliptical orbits that take them way out. Anything you can possibly imagine. And there's also that Goldilocks zone, that area of where liquid water can occur, that we consider a good zone for life as we know it, or other life capabilities as well. Who knows, that we can't even imagine yet. If that's the case, then you can just have fun, and you're probably gonna, with your mind, and you're probably gonna be right. So I was walking along just now, and I was trying to think of different worlds, and the one that came to my mind was a world. You know, there's planets like Venus. Venus has a really slow orbital period. It orbits, a rotational period. It rotates one time in about just a little bit longer than it takes the planet to go around the sun. It's very, very slow. That's because a long time ago Venus had a collision with a large body that slowed it down and stopped its fast momentum. It's moving so slowly. So one day lasts a long time. What if you had a planet that its rotational period was so slow that it had basically this Goldilocks zone on the planet that wasn't really an area of the planet defined by latitude or longitude, but an area defined by the amount of sunlight that it was receiving from its star, and that anything too deep into the night would be too cold for life, and anything too far into the day would be too hot for life. There would be this one zone, but it moves so slowly that zone creeps across the planet. What if there was life of some sort that could exist only in that zone, but because the planet moves so slowly that the life then creeps across the planet like a carpet, moving across the planet as it goes throughout its single rotation? Imagine that. Well, so wave of life sweeping across the planet as it moves across, not covering the whole planet, but just in that one little zone that's favorable to life. What if that was a possibility? What if there was a planet like that? Now I'm running out of time. It's time for me to get to work, but I'm going to stop the camera now. I'm going to continue throughout the day today, enjoying different speculations about different types of planets that might exist out there. What kind of binary system stars might. We just found also this week a confirmation of a binary system, two stars that actually a white star like ours and a little white dwarf orbiting one another with a nice gas giant planet going around. First time to confirm, we have actually found one. It's like that Tatooine on Star Wars, and actually that planet actually has the temperature. It's just on the outside edge of the Goldilocks zone. The hot temperature for that planet is about 80 degrees. I mean, it's a gas giant, so there's no rocky surface that could be. There is a rocky surface deep inside, but nothing. There's no life like we'd know it. Probably maybe cloud creatures like Carl Sagan once imagined. Fascinating. I mean, you can see I'm so excited, and my whole day is going to just be lots of fun thinking more about this, and we are going to discover more and learn more, and our speculations, given that there are so many planets out there, our speculations and our imaginations will probably not even come close to the fascinating diversity and reality that is truly out there. Take care. It's time for me to get to work. Take care, everybody. Have a great day. Bye-bye. 1.7 times 10 to the 11th. That's a big number. See you.